Okay. Okay, cool. 847, shortest path visiting all nodes. An undirected connected graph of n nodes is given as an input graph. Graph.length is equal to n, and j of j not equals to I is in the list graph sub I exactly once if and only if nodes I and j are connected. So you have a adjacency list, it seems like. Return the length of the shortest path that visits every node. You may start and stop at any node. You may revisit nodes multiple times, and you may reuse edges. Okay. So this is n is just 12. So I think that's okay. Okay. So I like this problem. Well, for some definition of that, but well, the only thing that makes this possible. So yeah, I mean, you could revisit nodes, which is also maybe useful. But oh, Chris. Oh yeah, sorry. Yeah, I stopped on a dot. Do I want Python in this? Yeah, it's fine. Probably. I should practice more Python anyway. Yeah. The thing that makes this, you know, I wouldn't say easy, but easier, is that n is only 12, right? So you could do very brute force e things for sure. Not so brute force e thing because the most brute force e thing is probably like 12 factorial or something like that, which is still too big. 480 million. Okay, it's not actually in theory doable, but do we want to do it that way? No. We could do it. We could still do better. Yeah, there are a couple of things we can do. I want to use C because I want to play around with or C++ maybe because I should practice C++ at least because I already know C. Um, for a reason that I'll show you in a bit. Maybe that's not a good reason. Well, I want to use because I want to do I want to create a matrix. That's why I want to use C++ because I know in Python they're like not real matrix. I mean they're like what's the difference? Like they're not matrix. They're just multi-dimensional arrays. If that makes sense, because then it could be jagged versus like an actual rectangular, in this case, square matrix. So yeah, so I'm going to do it in C++. That's the real reason why. It's not a big reason. Like you still do it. I mean, like you could manually force it, but I just prefer it that way. So the first thing I'm going to do, because n is 12, and maybe we could think about optimizing it later. But we're going to do the shortest path from every node to every node. Yeah, and you could do that with what's it called, Floyd-Warshall algorithm. I'm going to type it up so you could maybe I could type it up correctly. It'll be easy to Google. But that's just for the viewers. I mean, to kind of Google it a little off stream. So I don't have to explain it a little bit. But yeah, so we'll just use that later to kind of figure out the shortest path between all points. Then you could actually just calculate. And there's an optimization that we'll get into in a second. I know exactly how to solve this problem, I think. So that's why I'm kind of hand waving a little bit. Maybe in an interview, that's not great. Maybe I would explain it a little bit more. But I don't, in general, I also don't see these kind of problems on interviews, though, only because, and the reason that I'll point out in a little bit, because it's a little awkward. But well, I'm going to start coding and I'm going to describe what I'm coding. So I'm going to structure that or this problem this way instead. And also propose to write, I think it was supposed to write about dynamic program problems. It's another dynamic program problem to kind of for optimization. So so yeah, maybe also this one. There are a couple of dynamic program problems I'm bad at, but yeah. So yeah, let me get into that. And a graph problem. I love graph problems in general. They don't always love me. Okay, Navi lists have a question about I is in the list exactly once. If and only if node I and j are connected. Yeah, that phrasing is a little weird. I think it just means that yeah, each number that appears in a sublist will appear only once, and I guess they don't really define what J is, which is probably why you're confused. But J, I assume now looking at it, is it's an individual number in the list, and J is not equal to Y. So like this is the element 0 of graph sub I, sorry, element 0 of graph. So 0 would not be in this. So yeah, I think that's how I interpret it. It's an adjacency list, so that's how I interpret it, and I kind of didn't really look that deeply into it, to be honest. But I am going to convert this to adjacency array, which is, sorry, adjacency matrix, which you'll see in a second. Okay. Whew. That was a mouthful. Let me clear my throat a little bit and now start coding. I know the answer to this one, I swear. Okay. Cool. Okay. So now we have, let's just say shortest path. Okay. Yeah, I'm just gonna. I know max is 12, but I always like to pad myself just in case for what you would call it, off by one bound error stuff. Yeah, I guess I could just get n. But yeah, I should definitely at some point actually write maybe write one of those. I could be one of those cool kids with with a Medium post on how to use Leetcode or something. And I don't mean that in a condescending way. Sorry if it came out that way, but I just mean like I do get that question like a couple of times a stream, and I do try to explain every time because I do want to explain it, but yeah, I maybe that would be cool. Let me know if that's y'all think is useful if I do. Well, I mean, if you're on the stream, maybe you don't because you already heard me talking about the same thing multiple times. But yeah, but the max here should be max because you don't have to go that far. You can only go like a couple of nodes away. I think that should be okay. Yeah, I think I'll do this one. Yeah, I don't know. For me, it's just something that this is just like a hobby of mine, and also like good to keep up with my, with being with not, just good keeping in shape. I guess I have trouble typing and talking at the same time. At least talking about unrelated things. But yeah, I don't know. I don't know how I feel about it. I mean, like I said, I was a aspiring academic person, so like I don't know. All this money stuff is, yeah, maybe I just have, I don't know. Like I rather, I feel like I definitely had been very fortunate in many ways in different parts of my career, both, like different stages of whatever. Have been very lucky with kind of mentors and stuff like that, and this is kind of like my way to give back a little bit. But like my I's and J's don't match the prompt description, so I think this is right. Sorry, I'm talking while I'm typing, but yeah, I definitely try. Yeah, think about it is giving back a little bit to future generations of people. I don't know if that sounds too grandiose, but that's how I think about it. I don't really, um, otherwise, yeah. I mean, I don't know. But yeah, I also just happen to find this fun or like, it's stimulating, right? Like it's intellectual. Like I mentioned this before. Like some people do crossword puzzles, some people do Sudoku. I do these kind of things just to kind of keep myself sharp, and it's tangentially related to programming, so I keep myself a little sharp in that as well. So that's why I kind of do it. I no, I mean I'm not like outside of like a close group of friends or whatever. Sorry about that. I just think, for me, I'm getting up there in age. I think for me, time is a disproportionately valuable part of my life, and I don't know. And once you put money in things, things are stressful um, and like you have obligations and stuff like that. I feel like, I mean, I still try to do this every week, but in theory, you know, if you're getting it for free, if I don't show up a week or something because I'm out, I don't know, on a beach somewhere, like I hope y'all forgive me a little bit for it. But but yeah, I mean, I think there are a lot of resources, and I also a lot of my kind of in real life um, uh, in real life mentees. Sorry, I'm just like make sure I got this right. Uh, yeah, a lot of my real life mentees, all like by now actually like relatively senior, um, maybe not relatively senior, but like senior-ish. And then we kind of do it that way. So I don't even like sometimes it's kind of a little crappy to say, but I just maybe a little disconnected to the more junior people sometimes. Maybe I need to be better about it. Uh, but like, but I would also say that now more than ever, there are way more resources to, how to get better at interviews and algorithms and stuff like this. Like I think people alluded to even earlier. Um, so I don't think I don't have crazy amount of value proposition. I think like a lot of people could do it. So I'll leave it to them. Uh, okay. So what I just implemented the Warsaw or Freud Warsaw algorithm. Look, I mean, it's actually also considered a dynamic programming algorithm, which just calculates the shortest path for, a lot of things. You could actually rewrite this in a quicker way to make it not do the addition twice, but that's fine. Um, yeah, I'm not going to explain it because it's a standard A. It's not a standard EPROM, but algorithm, but it is something that is Googleable. And fun fact is that Freud Washer algorithm is probably like one of the earliest algorithm I learned, and I was just like, wow, this is just three for loops, and I could do the shortest path or paths. What the? This is like crazy magic. So definitely look that up because if I could learn it as a young kid, maybe you could figure it out too. I mean, that said, I learned how to code it. I didn't really understand it until many years later when I have a more refined algorithm training, if you will. Um, but yeah, okay. Can I start from anywhere? May start and stop at any node. Okay. Uh, oh, I want to start. I guess it sounds nothing. Okay. Calculate. I'm just gonna call it calculate. I know it's a generic thing. So, no, I don't want to. Okay. Oh, it doesn't really. Also, this is just. I forgot a dimension. Best is equal to what's best, or what's the worst case? Let's just say 1,000,000. I think that would be way high. Each goes and oh yeah, temporary result. I guess this is technically. I just don't want to. So what I'm doing is structuring in a way that I don't have to write an additional base case, but maybe I should have done it. If temp is smaller than best, then we go with that. And then now we can just return best. And this is this is the part of recursion. Recursion is also kind of my tip about recursion. I think because I'm doing recursion now, and someone asked about it, which is that recursion, I think, is just reframing a problem in terms of itself, which is literally the definition of recursion. I know, but what that means is kind of. I mean, I guess that is literally what it means. I don't know how. I don't. I guess I'm coming short on how to explain that particular one. But there are. I think this is like a very well studied or well YouTube people create a lot of videos about recursion. I think that's what I would recommend. I don't really have a. I don't think I could do it better than like thousands of YouTubers. I think this is so. I'm gonna leave it at that maybe. But because I guess because what I was going to say is that I'm going to do recursion right now, but DP recursion is kind of a special case of it, kind of, and I don't know. It's just already difficult even if you are good-ish at recursion. So I don't want to like set things up in a weird way. I don't know if I'm saying it right because I'm trying to code while doing it. But okay, I know I promised to explain my DP a little bit, which I think this is a good time. So I said because n is equal to 12, you could use this optimization, and x is maybe this is not a good variable name, but this is kind of okay, whatever. Let's just go to x because I don't want to change it, but because yeah, so this this dynamic programming function or this with memorization is just that I'm at node x right now, and these are the mask is it's a Boolean set of or like a bit mask or bit vector or whatever, except when it fits an int because there's only 12 possibilities, which means or n is equal to 12, so there's only 2 to the 12 possibilities, right? Yeah. So yeah, so mask represents like all the stuff that we've already visited, and one thing that I did, which I didn't talk about, is I know that you could visit the same path multiple times, but essentially, oh, I guess that's not the case. But oh no, we do visit 0 all the time. But because we calculate all the shortest path using the Floyd-Warshall algorithm, then 2 to 3 already has the distance of 2, which factors in visiting 0 again. So that's already factored in. So then we could do everything directly that way, treating it like we only visit each node once. Hope that was kind of a good enough explanation. Definitely ask in the comments if we go. So I will try to explain it a little better. But okay. Yeah, and this is just standard dynamic programming memorization. I don't know if I go over it, but yeah. Let me define it. Magic constant. I also have to. Move this here. Oh man. I guess I need more global things. I mean, these are just pointers. I could have passed it into the recursion, but maybe this is a premature optimization. But that's what I'm doing. Okay. So what's your other base case? Base case is if we visit all of them, right? So mask is equal to return 0 because you're done. You're done. Maybe this could go before. And it doesn't matter which other states. Now we just need a loop. I already did the best. If mask need a second bracket because of bitwise priorities, something I always talk about. That means if this is not used, then oh, I need a temporary variable or cost. I should have renamed the other one better. Cost. Cost is equal to calculate. You're going to I mask. You add this bit, and then the cost of going from x to I. So x to I. Why does this not autocomplete? Oh, actually no, that's just part of the calculate. Okay. And then now if cost is less than best, that's true cost. I think this is right. And you can't go to itself because these are true. Okay, let's just run this code. Oh. What? Why is that on that though? I guess there's infinity in math, so let's just do this then. Six. Did I reference this right? Oh. Well, I. J. Yeah. Oops. Man, I am hungry today. I guess that's why I don't remember that. So buffer overflow means. Did I mess up somewhere? Is this the other thing is 0, 1 indexed? Yeah, it should be okay. Oh, this should be. Yep, okay. Silly typo, hopefully that's it. Okay. Hey, Natalie. Nice of you to join us. Welcome. Okay, let's just try these two. And then maybe an empty case. No, I guess you need one, but let's try the one case then. Man, this is a weird day. But, okay, let's YOLO. Okay, cool. Wow, I slowed down a lot. Yeah, well, it's fine. Not gonna think about it too much. Man, this is like one of those weird backwards day where I'm like doing all the hards. I feel like I've done them really quickly, and all the mediums I've been just like struggling a little bit. It's one of those days, I guess. Yeah. How do I talk about this? So yeah. I think graph problems are always a little tricky, and this dynamic program problem because you have to do this bit mask thing. It's a little like it's a weird-ish thing that doesn't come up as much. So that's why for an interview problem, I generally don't do stuff that requires bit masks. At least as an optimization that is necessary. Like if I could do it in a like if you could, I don't know, maybe like do a bit array and then store that in a hash table, then maybe that would have been okay. But that usually the running time being way higher than it needs to be or should be, or it's just way higher anyway about that optimization. But that said, this is relatively yeah. So I'll go over the bits and pieces. I like certain parts of this problem as an interview, but I don't know if I like all of them. And in terms of cleaning the code, there's definitely a lot of cleaning I could have done that I didn't do because I kind of rushed through it a little bit. But it is in the way that I solved it. I solved this in half an hour, but I think I talked about other stuff during it. But for example, word for sure, I could have, oh, what did I do? I could have put this in a helper function for sure. These are just all, well, this is this is just resetting the code to put that in a helper. This kind of converts an adjacency list to an adjacency graph, so that could have been a helper function. Maybe this is the kicker for the recursion, so maybe that's fine. But maybe I could clean that up a little bit. I could have renamed this as cost. This is probably as short as sweet as it could get. So maybe I could have changed some variable names here and there, but probably not by that much. But yeah, so that's kind of the things that I would do to improve this. Overall, this algorithm is n cubed plus 2 to the n times n times, okay, n cubed plus n squared times 2 to the n, I think. And in space, it is n times 2 to the n plus n squared, I guess. So yeah, I guess I'll put it down somewhere just so I can remember it. Talk about it. So time is n cubed plus n squared times 2 to the n, I think I said, and I still think that's right. Space is O of n squared plus n times 2 to the n. I mean, the space is easy to do the math for only because, this is our space. These are rectangular arrays, so it's, you just look at, right? And you just multiply. Yeah, I mean, I think that's straightforward-ish. If not, you have to revisit some data, basic data structure. Well, n cubed comes from Floyd-Warsaw. May not be super necessary per se, but I think eventually eventually it comes in handy. So maybe that's unavoidable because it makes a lot of things easier. Yeah, so this is clearly n cubed because there's 3 for n for loops. I think that's clear. So there's n times 2 to the n subproblems for a dynamic programming problem, and each of these have n branches, if you will. So n amount of all of one work. So that's why it's n squared 2 to the n. So that's the time complexity. That's how I go about this problem. I don't know how I feel about it. I think this is a graph problem, but like I said, it's kind of a little brute force, but in a cool, smart kind of way. But it's in a way that is very straightforward if you have seen this kind of brute force or this kind of dynamic programming problem. Maybe I'll do a thing about different types of dynamic programming problems at some point. But because of that, I don't really like to ask these things on an interview. And I don't know if I would expect to see this on an interview. I think it's a little bit on the hard side. I mean, I know it's kind of funny because on the medium stuff I say it's easy, but I struggle with it, and I said that's too easy for it. And for this hard problem, I feel like it's still too hard for a normal person, even though I kind of relatively breezed through it. But it is like a 70 lines of code. But I mean, it's definitely way hard. It's just in the sense that like there's a lot of high level or like high power machinery, if you will, that like I just happen to know. But I these are also knowledge that I don't know if I would expect everyone to know. Like on an interview, right? I generally prefer more primitive algorithms, like binary search or sorting and stuff like that. And I try to make problems that are kind of related to one of those two things. Though if you gave me it's an interview, yeah, I may toss it. Don't take me on my word. But so that's why I wouldn't choose this problem. I think it's still a little hard for the normal people to be asking. Like I don't think I've seen anything similar. Maybe I'm wrong, but like I'm just trying to think if I've heard other people ask this type of problem, and I don't know if I have an example of it. So I think it's a little hard. It just happens that I know all the pieces about it. Yeah, so that's all I would say about this problem. Could I have done this faster? I mean, I think I solved this as fast as I could. I mean, I know I talked a lot during it, so not as fast as I could, but as fast as I could while talking through it. Yeah, so that's all I think I'm okay with moving on with this, unless anyone have any questions specific to this problem. I'll answer your question next. But yeah, Floyd-Warsaw is just one of those things where, I mean, that's why I did kind of hand waved over it. I mean, there's a good Wikipedia article about it. So that's what I would recommend. And it's one of those things that would literally, like I said, this part is an algorithm or like a research paper, right? I mean, it has two people's name on it, two kind of famous people too. Because Floyd did a lot of graphy stuff as well, and Warsaw did some other DPE things. But so like, like either you know it or you don't, because you're not going to prove this on a you're not going to prove this on an interview. So just take a look if you're interested, I think. And I don't think this should be on interview for it was sure. So, but that's my opinion. So I don't know if you get caught, apologies in advance. And but yeah, but it is once you do get it, it is like 3 for loops. So that's why I like it. But yeah, cool.